So when we write our own software, it is never the case that we have only one class and we are using only that class. Rather, for the object-oriented programming, we actually have multiple objects designed for multiple entities of the system we are developing. So these objects actually interact with each other in real life, and this interaction is programmed in our software by using relationship. So the common relationship among classes are association, aggregation, composition, and inheritance. In today's lecture, we will look into these three relationships, and in the next class we will actually look what inheritance is. So before we go into relationship, let's design an example problem. So our example problem in this case is a, a class management software. So in a class management software, the first step to design a class management software is identify the relevant entities of the problem. So this is not the case that we have to get all the entities in our first case. This is rather a development process. So let's say when we think of our class and what we need to manage in a class, we first come up with these three entities: students, faculty member, and a course itself. So after we come up with these entities, we need to design them as our objects or classes. So we have now three target classes in our design. As a next step, what we need to do is we have to think of the relationship between these classes. So how these three classes are related? We see that student take a course, faculty teach a course, and a course can have some multiple number of students and a faculty. So after we decide which class is related to which class, next we need to decide which class or which object relates to how many instances of the other object. For example, a student take multiple courses. A faculty teaches minimum 0 to maximum 3 courses. Then a course have a minimum 5 students to maximum 60 students in a class and one faculty member. So here we quantify the relationship. So after we quantify and establish the relationship, we redraw the UML diagram with all the relationship mentioned. For example, the student and the course class, these are the UML, the shorter version of UML diagram for these classes. So when we want to express that two classes are related, we will simply connect them with a straight line. So a straight line between student and course class means student and course class is related. Similarly, there is a relationship between course and faculty. So there is a straight line between course and faculty class. Next, we can also see that a student is not directly related to a faculty member. Similarly, in the UML diagram, there is no connection directly between student and a faculty member. So we have quantified the relationship here. Before we actually mark them, we see that when we draw the straight line between these two classes, we should name the relationship, and the name is simply the verb that relates the two classes. So the relationship between student and course, we can name them as take, and there is also a direction. So the direction is how we say the sentence in our real life. For example, student take course. So the direction is from student to course. Similarly, faculty teach courses. So the relationship between faculty and course class can be named as teach, and the direction is from faculty to course. So faculty teach course. So the triangle is into this direction. Afterwards, we have to quantify our relationship. So the quantifying number will be put with the class like this. For example, student take multiple courses. So multiple courses here, the number is kind of indefinite. It can be 0, it can be 1, 2, 3. There is no fixed value. So if a number is like this, we will put a star or asterisk sign here, and it will be put like this. So student take multiple, that means indefinite number of courses. So this asterisk sign will be with the course. Then faculty teach 0 to 3 courses. So faculty teach this 0 to 3 will be marked here with the course. So it is like the lower limit dot 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 the upper limit 0 to 3. Then courses have 5 to 60 students. So if we do it like this, courses have 5 to 60 students. So the lower limit 5, the upper limit 60, and this will sit with the student. And then courses have one faculty, so one will sit with the faculty. So with so far design information, we can actually start writing the base code for these classes. So in our student.java class, we have seen that student take some courses. So we can put a course array to have all the list of courses. So this course list, the array of course, will be a data field for the student, a private data field. Then we can have another method, that add course method, which will take a course type object as input. So course new C will be our input object for the add course method. Then we can have the next class, the faculty.java. So similarly, since a faculty teaches multiple courses, so there should also be a course list, which is just a course array, the array of courses as a data field. We can have another method, add course, and the input parameter is course type object. Then we can have the course.java. So in the course, for a course, there is a list of students and there is a faculty member. These two are also its data fields. That means the class list is a student array. Then since there is a single faculty for a section, so there is a faculty type object named faculty. Then a course will have add student method, which will take input a student object, and a set faculty method, which will take input of faculty object. So we will see that this type of relationship, we have seen that, okay, in our design, the classes are related to each other. We have named the relationship, we have quantified the relationship, but in the code, there is nothing different or no new keyword or anything that will mention the relationship. Rather, using another class as its data field and using specific methods actually depicts the relationship. So any sort of relationship, so it's called association between classes. So the relationship association, it's a general binary relationship that describes an activity, any type of activity between two classes. So these associations can be implemented by using data fields and methods. For example, the student array and the faculty, these two data fields are making the relationship between course and student class, course and faculty class. So for example, another example, the relation is student takes a course is implemented using the add course method in the student class and add student method in the course class. Perhaps you think about your own RDS system. So when you register for this class, CSE 215 section X, so what you had was this CSE 215 course was added in your course list. Also, in the section number X, you were also added as a student. So a single activity of you registering for this course actually was implemented in two classes separately but in the same time. This is the class relationship and basic relationship. It's called association.